Hey folks, Mr. Dell here. We are looking at solving literal equations like formulas that have a bunch of different variables and trying to rearrange them basically mathematically to solve for a different variable within that context of that formula. So this is coming from CPM Math 2, Integrated Math 2. This is section 7.2.2, numbers 7-95. So it says rewrite each of the following equations as indicated. So for A, it tells you the equation that we're going to work with is the force of gravity, F. So it defines what F is. F is the force of gravity between two masses. So my two masses are defined as M, lowercase m, and capital M. For a given distance, and r is defined as that distance, is given by this formula. The formula is uh, force F is equal to, so it should have an F in there. So the force is equal to uh, G times M, all divided by R squared, where G is the gravitational constant. So G is just a constant. And so it defines all my variables, but I have this, so I'm going to bring this down here, rewrite it. F is equal to G, lowercase m, capital M, all of that being multiplied, right? When you have variables next to each other, and there's no space in between them, we're dealing with multiplication. So it's G times M, and then all of that is divided by R squared. What it wants us to solve the formula for R. So I need to manipulate this equation to get my R alone is what I'm looking to do, right? So the first thing when you're dealing with this is I've got my R in my denominator, so I'm going to go ahead and multiply both sides by R squared. Because if I multiply by R squared over 1, when you multiply any single term, you can actually put it over 1 and make it a fraction. When you have a fraction times a fraction, what we've got here is these two, the R squared and the R squared cancel on this side. Okay, so when I do that, I have what I do to one side of the equation or the formula I do to the other, right? So now I've got my R squared times F. So my next line here would be R squared times F is equal to G times M times M. So now I need to get my R squared. I'm trying to get R squared alone. And R is now on this side of the equation. So again, my goal is to get R alone. So what would I do next is I've got this F being multiplied by the R squared. So I'm going to divide both sides by F, the inverse operation, in order to cause that F to cancel or to divide out on this side. And what you do to one side of the equation, you always do to the other. So I'm going to continue it over here. So now I have R squared is equal to G times M, all divided by F. Last thing is I need my R, not R squared. So the inverse, or to undo a squared, you use square root. So I'm going to square root both sides of the equation, because the square root of R squared is R. And now the other thing to remember, when you use square root within solving an equation, what you have is you have a positive and negative answer, right? So because R squared could be negative, R could be negative, because when you square a negative, it becomes a positive. So you could have a negative or positive of what I have over here, which is the square root. I'm just going to leave this as is, the square root of G times M, all divided by F. So that would be solving for R, getting my R alone. All right, let's look at the next one. It says the amount of torque T. So another formula we're dealing with here. So they define my T as the amount of torque for a given amount of force F. So again, F is my force at a given distance R and over a certain angle. Okay, Q can be calculated by the formula. And here's my formula. T is equal to R times F times the sine of theta. So that certain angle is that theta. Theta is my angle. All right, so that's the Greek letter theta. So what do I want theta by itself. So first of all, I need to get the sine. I need to get this isolated. So let me rewrite my formula again. So T is equal to R times F. So torque is equal to the distance times the force times the sine of theta. So to get my sine alone, remember this is all multiplication. So to undo, or the inverse of multiplication, is division. So if I divide both sides, when we have an equation, you do to one side, you do the other. So I divide both sides by RF, and I did that. So these R's and these F's can divide out and be 1 on this side. So that leaves my sine of theta isolated. And sine of theta is equal to the T, the torque, divided by the distance times the force. So to find theta now, once you have your sine function, your trig function by itself, to find the theta, you use inverse trig, right? So we would have theta be equal to the inverse sine. In inverse trig, you use this sine to the -1. That sine with the -1 subscript is inverse. This is inverse trig of what I had over there, which is T, the ratio T divided by R times F. So that right there would be solving for theta for this formula. Okay. All right.